PTO clutch brakes. Ogura PTO clutch brakes are used on a variety of outdoor power equipment. They are designed to transmit power from a gas or diesel engine to a rotating implement, such as a cutting blade. When the clutch is turned off, the armature of the clutch rubs against the brake cover to help slow the rotating implement. Ogura PTO clutch brakes come in 4 major series. Ogura provides a variety of pulleys and/or output hubs, but can also produce custom outputs where required. Many clutch series also have optional electrical connectors such as Packard, amp, and WeatherPack. Hub output clutches allow customers to use their own pulley and/or sprocket. Ogura also provides a variety of forged, rugged, double-groove machined pulleys. Electromagnetic PTO clutch brakes. Electromagnetic PTO clutch brakes are primarily used in the outdoor power equipment industry to start the rotation of an implement like a cutting blade, and also help to slow the implement when the clutch is turned off. Typical applications are homeowner lawn and garden tractors, stump grinders, commercial mowing equipment, portable sawmills, construction equipment. PTO clutch brake designs have either an adjustable brake shroud or 2 opposing flippable brake pads, like the one shown in this animation. Ogura PTO clutch brakes are one-piece designs. The key components to the clutch are output pulley, armature, rotor, brake plates, and the field assembly. Electromagnetic PTO clutch brakes operate via electric actuation, but transmit torque mechanically. The clutch brake consists of an electric clutch and a mechanical brake. When voltage or current is applied to the clutch, the coil becomes an electromagnet and produces magnetic lines of flux. This flux is then transmitted between the small air gap between the field and the rotor. The rotor then becomes magnetized and sets up a magnetic attraction loop between the rotor and the armature. PTO clutch brakes use either a double or triple flux design. So as the flux travels from the rotor to the armature, it makes multiple points of contact, amplifying the torque being transferred, helping to maximize torque and reduce weight and size. When the PTO clutch is disengaged and the brake is engaged, there is an air gap created between the armature and the rotor, so there is no contact. When the clutch is engaged, the brake becomes disengaged and there is an air gap between the top of the armature and the brake plates. When the magnetized rotor and armature attract each other, the clutch slips for a short time on initial engagement. The time depends on the speed and the inertia being accelerated. The torque is transmitted from the armature through the leaf springs into the pulley. The springs need to run in tension, not compression, so clutches are either built to run clockwise or counterclockwise. When the clutch is fully engaged, torque transfer is 100% and there is no relative slip. When the current or voltage is removed from the clutch, the magnetic field degrades quickly and springs pull the armature away from the rotor and against the brake plate, causing a mechanical drag on the armature and pulley, which helps to slow down whatever the pulley is driving. In all outdoor applications, friction material is not used and contact is made via steel on steel. Prior to removing or installing any PTO clutch brake, follow engine manufacturer's recommendations of either disconnecting the battery and/or removing the spark plug wire. PTO clutches are almost always directly mounted on the engine shaft. If they are not, they are mounted on a jack shaft. The shaft should be long enough to support the clutch. minimum shaft length needs to equal the bore diameter. Although most Ogura clutches are one-piece designs, some older versions are two-piece designs, so both halves need to be supported by the shaft. The engine shaft needs to have a step in it, and the engine shaft needs to be tapped. For clutches without a through bore, the key should be short enough that it does not hit the pulley bearing carrier. Clutches mount with the pulley facing toward the engine or away from the engine. So clutches are unidirectional, and the leaf springs on the clutches are set at the factory to run either in a clockwise or counterclockwise rotation. It is important to check the direction of rotation to verify that your spring direction is correct. The springs should operate in tension and not compression. Most engines operate counterclockwise. For this installation example, we will use a typical zero-turn mower. Some mowers have horizontal shafts. However, for the majority of tractors and zero-turn machines, the engine shaft is mounted vertically and sticks through the frame. A ground drive pulley is attached to the engine shaft to run the hydrostats, and then a clutch is placed at the end of the shaft to turn the cutting blades on and off. The clutch is attached to the engine shaft via a center bolt and washer assembly. The washer should be large enough to contact the inner bearing race face. Before installing the clutch, make sure there is no debris blocking the bolt from going into the shaft. During final assembly, make sure you use a locking adhesive to prevent the bolt from backing out from vibration. It is very important that the field bearing of the clutch contact the face of the ground drive pulley or spacer if no ground drive pulley is used. The field bearing inner race is the shiny silver surface. Contact should not occur on the hub bore face. Slide the clutch on the shaft. Some PTO clutches come with internal keys, so the clutches simply slide on to the engine shaft. For models that require a key, the key would be inserted first, and then the clutch would slide on. The center bolt is inserted into the tapped portion of the shaft and tightened down to the bolt's recommended tightening torque, which is typically 30 to 60 pound-foot. A locking adhesive should also be used. Make sure the clutch torque restraint is lined up properly. Make sure the engine and switch are off and connect clutch terminal. Different machinery manufacturers use different methods to retain the backplate of the clutch. Restraint of the backplate is important to achieve proper braking. Some customers use a slot, others flexible belting, and some, shown here, capture a rubber block that helps dampen noise and vibration. Most clutch parts don't require maintenance and cannot be replaced. Bearings are sealed for life of the clutch. Armature, rotor, and brake wear evenly and cannot be replaced individually. Coil cannot be removed. All Ogura one-piece clutches are adjusted at the factory. No initial adjustment is required. As adjustable clutches wear, they can be re-gapped to extend overall life. If the clutch fails to pull in or will not continue to pull in when hot, the air gap may need adjustment. Clutch can be adjusted on or off the mower. However, taking it off may be easier. A series of feeler gauges and a 9/16 open box wrench is required. Identify clutch model from the label located on the back of the field. There are 3 inspection slots on the brake shroud. Based upon the model type you have, the clutch should be set to within the air gap range shown. On the machine, the air gap should also be checked in all 3 locations, and if needed, an adjustment can be made to quickly reset the air gap. Setting the gap towards the low range will increase cycle life between adjustments. However, as a word of caution, do not set the air gap below the minimum, or the brake shroud may drag and cause the clutch to fail. This adjustable air gap feature can save end users downtime and money on replacement clutches, since this simple adjustment can allow the clutch to extend its life versus simply throwing it away once the air gap becomes too large. A newer version from Ogura has a one-time adjustment. When the air gap becomes too large, the brake plates can be flipped to help reset the gap and increase total cycle life. As the clutch goes through its normal cycling, wear occurs on the brake plate. After a certain point, the armature will not pull in, so to help reset a portion of the air gap, the brake plate can be flipped to the unused side. Step 1. Remove PTO clutch from machine. Step 2. Hold the angle portion of the brake plate in a vise and support the opposite end of the clutch. Failure to do so may twist or bend the brake plate. To prevent scratching the plate, you may wish to put a cloth on the vise face. Step 3. Remove the 2 bolts holding the plate in place. Note, bolts are held with thread locking adhesive, so it may take a little force to break the threads loose. Step 4. Make sure the plate is clean and free of debris. Flip the plate over. Step 5. Apply thread locking adhesive to the bolts. Step 6. Reinsert the flipped brake plate. Insert and tighten both bolts to a torque of 15 foot-pounds. Step 7. Reassemble the PTO clutch from the vise and reassemble on the mower. To achieve full torque, new clutches need to have an initial wear-in period. Depending upon inertia and speed, the wear-in period can be anywhere from 30 to 100 engagements. Burnishing should be done at a reduced RPM and at a reduced clutch load. For high inertia loads, do not cycle the clutch more than 4 times per minute.